Toyota is the king of internal combustion engine cars. However, the Japanese giant is shifting from making fossil fuel-powered cars because of their environmentally polluting nature. This is why it has turned to a new type of fuel, hydrogen. Toyota has developed a new hydrogen car that shocks the industry, but many in the buying public have many questions like, what does Toyota's new hydrogen car offer? How does the new car work using hydrogen? And what are the advantages of hydrogen cars? Hydrogen is abundant in nature. It is present in water, which is the most abundant compound on Earth. Hydrogen also exists in almost all organic compounds, including your body, where it makes up about 61% of all the atoms. It is not surprising then that somebody would think of using hydrogen as fuel to produce energy. So if you want to power a car using hydrogen, how does this work? There are actually two options that you can choose from. One is the hydrogen engine and the other is hydrogen fuel cells. Both are different technologies even though they use the same fuel. Hydrogen engines have been receiving increasing attention in applications like medium and heavy-duty trucking applications. They are basically internal combustion engines that burn hydrogen instead of gas. The benefits of using hydrogen this way include being built upon today's modern and reliable internal combustion engines. For vehicle manufacturers, it is a familiar technology to use in their vehicle design and production. Similarly, for fleet operators, it is a familiar technology to operate, maintain, troubleshoot, and service. Cummins, an engineering company that is involved in hydrogen engines, predicts that medium and heavy-duty applications are much more likely to turn to hydrogen fuel cells or hydrogen engines. The company further says it is likely in the coming decades buses and long-haul trucks running on hydrogen are going to become a common sight. You are also likely to see more hydrogen engines in off-road machinery, construction equipment, agricultural machinery, and even ships. These are most likely going to be the applications that are hard to electrify due to their use cases and mission profiles. Hydrogen engines can also become more prominent in electricity production. The other method of using hydrogen as a fuel is the hydrogen fuel cell, which Toyota has embraced fully. You might be surprised to learn that hydrogen fuel cells do not include burning hydrogen. Also, a hydrogen fuel cell car is similar in many ways to an electric car. So how does a hydrogen fuel cell car work? First, hydrogen fuel cells work outside cars, so you can find them in other applications. In a hydrogen fuel cell car, what is going on is that the hydrogen fuel cell unit produces electricity, which is then used to power the electric motor and other electrical systems. So you will find many parts in common with a battery electric vehicle. The polymer exchange membrane fuel cell, PMFC, is one of the most promising fuel cell technologies. It uses one of the simplest reactions of any fuel cell. A fuel cell contains four main components. The anode, the negative post of the fuel cell, conducts the electrons that are freed from the hydrogen molecules so that they can be used in an external circuit. It has channels cut into it that disperse the hydrogen gas equally over the surface of the catalyst. The cathode, the positive post of the fuel cell, has channels etched into it that distribute the oxygen to the surface of the catalyst. It also conducts the electrons back from the external circuit to the catalyst, where they can recombine with hydrogen ions and oxygen, forming water. There is also an electrolyte, just like in a battery, which forms the proton exchange membrane. This is a specially treated material, even though it might look like an ordinary kitchen plastic wrap. It conducts positively charged ions but blocks electrons. For a PMFC, the membrane has to be kept hydrated to work properly and remain stable. A hydrogen fuel cell also has a catalyst, a special material that promotes the reaction of oxygen and hydrogen. It is usually made of platinum nanoparticles, very thinly coated onto carbon paper or cloth. The catalyst is rough and porous so that the maximum surface area of the platinum can be exposed to the hydrogen or oxygen. The platinum-coated side of the catalyst faces the polymer exchange membrane. When applied in automobiles, the manufacturer adds a fuel tank where the hydrogen is stored and an exhaust where water vapor, the byproduct, escapes from. But why is Toyota going with hydrogen fuel cells? One reason is pollution reduction, because the byproduct of hydrogen fuel cells is water, which is harmless. The fuel cells are also very efficient. If the fuel cell is supplied with pure hydrogen, you could get up to 80% efficiency. This means it converts 80% of the energy content of the hydrogen into electrical energy. We must account for the loss of energy when converting the electrical energy into mechanical work, which is done by the electric motor and inverter. Typically, a motor-inverter system can be 80% efficient. This leaves us with about 60% efficiency for a hydrogen fuel cell car. This is an optimistic estimate, and real-world values may be different. Even in the worst-case scenario, hydrogen fuel cells are more efficient than gasoline engines that can only manage between 30 and 35% in the best-case scenario. Toyota started working on the development of fuel cell vehicles back in 1992. In 2014, the carmaker launched the Mirai, a hydrogen fuel cell sedan. However, to expand its hydrogen technology from cars to more diverse applications, Toyota has repackaged the advanced fuel cell system it used in its Mirai saloon into compact fuel cell modules. It planned to start production of these second-generation modules in 2022. The new system has been packaged into modules that are more compact, lighter in weight, and provide greater power density. They're available in two formats, a cube and a flat rectangular shape, allowing greater flexibility and adaptation for different applications. It can also provide more than 500 kilometers driving range, better than what many battery electric vehicles can do. Toyota will assemble the second-generation fuel cell modules using a manufacturing team at the Toyota Motor Europe TME Research and Development Center in Brussels. The new facility contains a pilot assembly line combining advanced technology content with high-quality assembly techniques. Apart from the Mirai, Toyota has had a hand in the development of larger hydrogen fuel cell vehicles. These include a bus called the Sora and prototypes of heavy-duty trucks. Remember the hydrogen engine we mentioned earlier? Toyota is deep into that as well. Last year, it announced a hydrogen engine it was developing. It installed the engine on a racing vehicle based on the Toyota Corolla Sport, which it planned to enter in motorsport competition. The car uses an engine that generates power through the combustion of hydrogen using fuel supply and injection systems that have been modified from those used with Toyota's gasoline engines. As such, the high-performance car produces zero CO2 during racing. The car benefits from the combustion of hydrogen occurring at a faster rate than in gasoline engines, resulting in a characteristic of good responsiveness. It also has the advantage of producing all the exciting sounds and vibrations that car race enthusiasts like to hear and feel. One part of hydrogen fuel cells is making the engine or fuel stack. The other part is producing the hydrogen that will fuel it. The second part is just as important because without it, the car cannot work. So Toyota is deeply invested in setting up infrastructure for hydrogen supply. The end game is to have hydrogen filling stations just like gas stations where you can pull in and pump hydrogen into your tank. For example, Toyota made arrangements to fuel the hydrogen-powered race car using a hydrogen produced at the Fukushima Hydrogen Energy Research Field in Nami Town, Fukushima Prefecture. However, for hydrogen cars to be accepted globally, Toyota has to expand this hydrogen supply infrastructure significantly. The challenge is to produce enough hydrogen to power a global fleet of hydrogen cars. While hydrogen occurs abundantly in nature, extracting it is not so easy. In fact, hydrogen is a controversial source of energy because the majority of the world's supply comes from non-renewable sources. But Toyota has a novel approach, producing hydrogen from cow manure. So your nourishment and car fuel will come from these four-legged creatures. In pursuance of this, Toyota announced the Trigen project at the Los Angeles Auto Show. The project claims to be the first facility in the world to produce hydrogen with 100% renewable power, which will be methane gas captured from dairy cattle manure. The power plant will generate water, electricity, and hydrogen. The hydrogen from the plant will power the Toyota Mirai and the trucks produced from Toyota's Project Portal. The project, when fully operational, would produce 2.35 megawatts of electricity and 1.2 tons of hydrogen every day. Toyota is working with a fuel cell startup known as Fuel Cell Energy. The company has been developing its own power plants that can separate water, hydrogen, and carbon dioxide from natural gas. Let's hear what you think of Toyota's hydrogen cars in the comment section below.